Hey everyone, how you guys doing today? Moving on to chapter 8. Chapter 8. All right. Um this is what is chapter 8? Chapter 8 is strings and regular expressions. Okay. Let's see where we get into this. I dislike regex. I have never been able to do regex well, but if you are not a beginner watching this, I recommend this website, Regex 101. Kind of helps you test out your rejects and stuff, which is really nice. So just showcasing that leaf page. I'm gonna run this first cell. Run anyway. Strings and regular expressions. Strings are not like integers, floats, and booleans. A string is a sequence, which means it contains multiple values in a particular order. In this chapter, we'll see how to access the values that make up a string, and we'll use functions that process strings. We'll also use regular expressions, which are a powerful tool for finding patterns in a string and performing operations like search and replace. As an exercise, you'll have a chance to apply these tools to a word game called Wordle. Okay. um, String is a sequence of characters. A character can be a letter in almost any alphabet, a digit, a punctuation mark, or white space. You can select a character from a string with the bracket operator. This example statement selects character number 1 from fruit and assigns it to letter. So this would actually give you the letter A because Python is 0 indexed. So when you index into any type of sequence in Python, 0 would be the first element, 1 would be the second, etc., etc. So this should give us A. Uh, let's print it. Yep, it's A. Expression in brackets is an index, so called because it indicates which character in the sequence to select, but the result might not be what you expect. The letter with index 1 is actually the second letter of the string, and index is an offset from the beginning of the string. So the offset of the first letter is 0. So fruit 0 would give you B. You can think of B as the 0th letter of banana, pronounced 0th, etc., etc., or an expression that contains variables and operators, I plus 1. So yeah, you can do expressions as well when indexing. Neat. But the value of the index has to be an integer, otherwise you get a type error, which, yeah, duh. There's no decimal points when it comes to indexing lists or sequences. As we saw in chapter 1, we can use the built-in function len to get the length of a string. There you go. Length of fruit is 6. To get the last letter of a string, you might be tempted to write this, right? Fruit 6, which says index out of range because it is, because the last element is actually 5. And pro tip, you can index with -1 to get the last element straight away. But that causes an index error because there is no letter in banana with index 6 because we started counting at 0. The 6 letters are numbered 0 to 5. To get the last character, you have to subtract 1 from n. So fruit n minus 1 would be A. Wait, what? Oh yeah, banana. The last letter in banana is A, correct. Or, like I said, fruit minus 1. The index -1 selects the last letter, -2 selects the second last, and so on. String slices. So there is a thing called slicing in Python, where in the index, if you use the colon, you can say, hey, I want this slice of this sequence. So fruit 03 is actually the 0th element, the first element, and the second element. So BAN. You'd be tempted to think it'd be BANA, BANA, but when you have slicing operators, it's inclusive on the left and exclusive on the right, meaning that 0 through 3 actually gets you 0, 1, and 2, but not 3. There's also such a thing as slice assignment, which is a little advanced, but essentially, if, for example, you want to reassign a particular slice to some other sequence, you can do that. So there you go, string slices, BAN. The operator n through m returns the part of the string from the nth character to the mth character, including the first but excluding the second, which is I said. This behavior is counterintuitive, but it might help to imagine the indices pointing between the characters, as in this figure, which let's run these two slices. Yeah, so I don't understand how this figure is supposed to help us visualize that, but basically, yes, it's inclusive on the left, exclusive on the list. For example, the slice 3 to 6 selects the letters A and A, which means that 6 is legal as part of the slice, but not legal as an index. If you omit the first index, the slice starts at the beginning of the string. Yeah, so fruit colon 3 just will automatically get you BAN, and then fruit 3 colon will just get you ANA. Fruit 3 through 3 should be an empty sequence. Yeah, there you go, it's an empty string. And fruit with just the colon is an empty slice, wherein you just get everything. Once again, this is more useful for slice assignment than slice operations. Than slicing into a sequence, but that's a different story. Strings are immutable. It is tempting to use the bracket operator on the left side of an assignment with the intention of changing a character in a string like this. Okay, so this is technically valid, but not for all types. It's not valid for strings. It's valid for lists and other mutable sequences. But yeah, it's not valid for strings. The results is type error. In the error message, the object is the string and the item is the character we try to assign. For now, an object is the same thing as a value, but we will refine that definition later. The reason for this error is that strings are immutable, which means you can't change an existing string. The best you can do is create a new string that is a variation of the original. Correct, that is accurate. Which is why I was saying about mutable versus immutable. So this essentially creates a new string from the string greeting called Jello World, right? It's essentially a brand new string. It's not changing the same string. This example concatenates a new first letter onto a slice of greeting. It has no effect on the original string. Greeting hello world. String comparisons. The relational operators work on strings. To see if two strings are equal, we can use the equals operator. Word banana, if word equals banana, print all right banana. Other relational operators are useful for putting words in alphabetical order. If word less than banana, print word comes before banana. If word greater than banana, print word comes after banana. Else print all right banana. Compare word apple. Apple comes before banana. Yeah, so in this particular case, these sequences are comparable. And honestly, if I'm correct, you can make your own unique data types and classes that can be compared with each other using these operators. But then you have to define these thing called magic functions in the classes, which are like anytime you see double underscore something, double underscore, those are some reserved things that Python uses in its internals, but you can write your own as well. Compare word pineapple. Pineapple comes before banana. Python does not handle uppercase and lowercase letters the same way people do. All the uppercase letters come before all the lowercase letters. So okay, yeah. So that's something I didn't know about because I've never actually done string comparisons in Python. I don't know what the use case would be, but I guess for someone it's there. To solve this problem, you can convert strings to a standard format, such as all lowercase, before performing the comparison. Keep that in mind if you have to defend yourself against a man armed with a pineapple. I'm guessing that's a Monty Python reference. Yeah. String methods. Strings provide methods that provide a variety of useful operations. A method is similar to a function. It takes arguments and returns a value, but the syntax is different. For example, the method upper takes a string and returns a new string with all uppercase letters. Instead of the function syntax upper word, it uses the method syntax word.upper. This use of the dot operator specifies the name of the method upper and the name of the string to apply the method to word. The empty parenthesis indicates that this method takes no arguments. Yeah. So upper is a function. It's specifically a method of strings, of any string. So when you do that, it just turns everything into uppercase. A method call is called an invocation. In this case, we would say that we are invoking upper on word. Okay, so I feel like they're a little aggressive with the terminology sometimes, because I've never heard it called as an invocation. Because it's just a function, or you're just calling a method or a function, whatever you want to call it. I feel like this is a little too much, but whatever. Writing files. String operators and methods are useful for reading and writing text files. As an example, we'll work with the text of Dracula, a novel by Bram Stoker. Okay, we're getting the novel Dracula downloaded, and we are opening that file, which we can open for reading like this, as we discovered from the last chapter or last chapter. I don't know, at some point we use the open function. This is how you open up files in a program. In addition to the text of the book, this file contains a section at the beginning with information about the book and a section at the end with information about the license. Before we process the text, we can remove this extra material, finding the special lines at the beginning and end that begin with star, star, star. The following function takes a line and checks whether it is one of the special lines. It uses the starts with method, which checks whether a string starts with a given sequence of characters. Line dot starts with star, star, star. So yeah, starts with is another string method. We can use this function to loop through the lines in the file and print only the special lines. Oh, let me just define that first. Okay. Now let's create a new file called pg345 clean text. In order to loop through the book again, we have to open it again for reading, and to write a new file, we can open it for writing. So yeah, reader and writer. You can also give it, so the W is essentially the mode. You can open files with multiple modes, read, write, execute, I believe. Open takes an optional parameters that specifies the mode. In this example, W indicates that we're opening the file for writing. If the file doesn't exist, it will be created. If it already exists, the contents will be replaced. As a first step, we'll loop through the file until we find the first special line. Okay. For line and reader, if is special line break, the break statement breaks out of the loop. That is, it causes the loop to end immediately before we get to the end of the file. When the loop exits, the line contains the special line that made the conditional true. Start of the Project Gutenberg ebook. Okay. Because reader keeps track of where it is in the file, we can use a second loop to pick up where we left off. The following loop reads the rest of the file one line at a time. It finds a special line that indicates the end of the text. It breaks out of the loop. Otherwise, it writes the line to the output file. So, bam. So, essentially, for each line, if it's the special line, we're just going to break out of the loop. Otherwise, we're just going to write it to the new file. When this loop exits, line contains the special exit line, which it does. At this point, reader and writer are still open, which means we could keep reading lines from reader or writing lines to writer to indicate that we're done. We can close both files by invoking the close method. Boom. So a better way to deal with files is to use context managers, which is the with keyword. So with open blah, blah, blah. Anything that has a Python magic function for it denoted, I think I think it's just called context manager or something like that. But there is specifically a Python magic function that you can define, and using that you can use with that, even if it's your own custom class, right? To check whether this process was successful, we can read the first few lines from the new file we just created. For line in open blah blah blah, line equals line dot strip. If len of line greater than 0, print line. If line dot ends with Stoker, break. Ends with method checks whether a string ends with a given sequence of character. Find and replace. In the Icelandic translation of Dracula, from the name of one of the characters was changed from Jonathan to Thomas. To make this change in the English version, we can loop through the book, use the replace method to replace one name with another, and write the result to a new file. Total equals 0 for line in open PG34. Okay, so this is just reading the number of lines, which is 15,285. So it just opens it, iterates through it, and updates this counter variable called total. To see whether a line contains Jonathan, we can use the in operator, which checks whether this sequence of characters appears anywhere in the line. Total equals 0 for blah blah blah. If Jonathan in line, total plus equals 1, total. This once again just prints the number of occurrences of Jonathan. We have 193. Oh, the 199 lines that contain the name, but that's not quite the total number of times it appears, because it can appear more than once in a line. To get the total, we can use the count method, which returns the number of times a sequence appears in a string. So essentially, this is just going through all of the different methods for strings, and I'm assuming at some point we're going to get a regex as well. So line.count is another one, and I get 194, which is still not the same. Now we can replace Jonathan with Thomas like this. We can just do line.replace. The result is a new file called pg345 replaced, because that's the name of the file that we created. And boom, we check the number of times Thomas is found, which you can see here, 201, which doesn't make sense. How did Jonathan get replaced more times than it existed? But whatever. Regular expressions. If we know exactly what sequence of characters we're looking for, we can use the in operator to find it and the replace method to replace it. But there is another tool called a regular expression that can also perform these operations and a lot more. To demonstrate, I'll start with a simple example and we'll work our way up. Suppose again that we want to find lines containing a particular word. For example, let's look for a reference to the titular character of the book, Count Dracula. Here's a line that mentions him. I'm Dracula, and I bid you welcome, Mr. Harker, to my house. I should read this book. Sounds fun. And here's the pattern we'll use to search. Pattern equals Dracula. A module called RE provides functions related to regular expressions. We can import it like this and use the search function to check whether the pattern appears in the text. Okay, so we've given it the pattern, which is basically the string Dracula. Oh, wait. I'm just going to run both of these before running this again. And yeah, you essentially get a match object. And this match object will contain the occurrences or the results of the search. Among other information, it has a variable named string that contains the text that was searched. Interesting. Result.string. Okay, so this gives you the string that was searched. It also gives a method called group that returns the part of the text that matched the pattern, Dracula. And it provides a method called span that returns the index in the text where the pattern starts and ends. Boom. If the pattern doesn't appear in the text, the return value from search is none. Also true. So you can just go if re.search blah 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 to make it Pythonic in that way, because none is evaluated as false or non-existent. So when you put it in a conditional expression, it evaluates to false. Oof. Putting all that together, here's a function that loops through the lines of the book until it finds one that matches the given pattern and returns the match object. Find first for line open, blah blah blah, result blah blah blah. If result not equals none, return results. We can use it to find the first mention of character, Mr. Harker, result.string. Jonathan Harker's Journal, Chapter 1. Okay. For this example, we didn't have to use regular expressions. We could have done the same thing more easily with in operator, but regular expressions can do things the in operator cannot, which is true. For example, if the pattern includes the vertical bar character, it can match either the sequence on the left or the sequence on the right. Suppose we want to find the first mention of Mina Murray in the book, but we're not sure whether she's referred to by first name or last. We can use the following pattern, which matches either name, Mina or Murray. Find first pattern, result.string. We can use a pattern like this to see how many times a character is mentioned by either name. Here's a function that loops through the book and counts the number of lines that match the given pattern. Count matches, count for line and open, blah blah blah. If result not equals 1, none, count plus equals 1, return count. Count matches, Mina or Murray. Okay. This should just return the number of occurrences of the word Mina or Murray, which it does. Murray? I don't know how to pronounce her last name. The special character caret matches the beginning of the string, so we can find a line that starts with a given pattern. Yeah. So like that. Add the special character dollar matches the end of a string, so we can find the line that ends with a given pattern, ignoring the new line at the end. I'm gonna start off for it won't be to leave Mrs. Harker. Okay. So yeah, dollar is for the end of the line and caret is at the beginning of the line. Or string. Bram Stoker was born in Ireland, and when Dracula was published in 1897, he was living in England, so we would expect him to use the British spelling of words like center and color. To check, we can use the following pattern, which matches either center or the American spelling center. So yeah, you can, with the parentheses, you can say like this and then this or this, you know. In this pattern, the parentheses enclose the part of the pattern the vertical bar applies to. So this pattern matches a sequence that starts with cent and ends with either ER or RE. Horseshoe of the Carpathians, as if it were the center of some sort of, okay, I don't know what this is talking about. Center. Okay, so this is just, okay, just ran find first with this particular pattern. As expected, he used the British spelling. We can also check whether he used the British spelling of color. The following pattern uses the special character question mark, which means that the previous character is optional. So yeah, okay. This is actually teaching me a decent amount about regex as well. Like, I kind of know regex. Like, I know what it is. I just never screwed with it too much. I just use it when I need to use it. And then whenever I do need to use it, I usually copy something from Stack Overflow or ChatGPT, to be honest. But interesting. Though you can't be reliant on that, because like I've done the ChatGPT thing in the past and it kind of works. It gets you like a decent amount of the way there, but be careful if you have like a genuinely complex regex. Don't just copy paste that shit, because ChatGPT is not smart. Again, as expected, he used the British spelling. Now, suppose we want to produce an edition of the book with American spellings. We can use the sub function in the re module, which does string substitution. Nothing seems to stop or even to hinder them, neither the find and replace. The second is what we want to replace it with. And the third is the string we want to search. In the results, you can see that color has been replaced with color. Oh, first let me do that, then do this. Front and back of colored stuff. Colored, yeah, okay. First argument is the pattern we want to find and replace. The second is what we want to replace it with. And the third is the string we want to search. In the result, you can see that color has been replaced with COLOR, color. Boom, boom. Here's the pattern I use, which makes use of some features we haven't seen. Jesus Christ. Okay, that's a lot. So this one is essentially going for all matches and not the first, not just the first. So that's why you got a lot over here. I'm not going to go through all of that. Debugging. When you are reading and writing files, debugging can be tricky. If you are working in a Jupyter notebook, you can use shell commands to help. For example, to display the first few lines of a file, you can use the command !head like this. Yeah, okay, there you go. Tail like this. When you're working with large files, debugging can be difficult because there might be too much output to check by hand. A good debugging strategy is to start with just a part of the file, get the program working, and then run it with the whole file. To make a small file that contains part of a larger file, we can use head again with the redirect operator, which indicates that the result should be written to a file rather than displayed. Boom. Yeah, so that's like a piping, that's like a bash and shell terminal thing. There's piping and redirection. I think that's what they're called. Piping is where you feed the output of one bash command into another, and redirection is when you redirect the output of one to someplace else. It's linked but distinct concepts. Very common thing in computer science. By default, head reads the first 10 lines, but it takes an optional argument that indicates the number of lines to read. So you can just do head-100, and it works. The shell command reads the first 100 lines from blah and writes them to a file called blah. Note the shell commands, just like a little note on how to use shell commands in Jupyter Notebook, which, yeah, go for it. Learn your shell commands. You should definitely learn shell commands for sure, but don't just learn Jupyter Notebook. I feel like recently I've been thinking about this, and Python seems like an easy place to start, but if you're trying to get someone working in Python in a production environment, I think Python is actually harder to learn and use than like a statically typed language like C or C++. But that's just my 2 cents, or maybe even Java. Go, I guess. I don't know if Go is strongly typed or statically typed. Anyways, so let's go through some of these exercises really quickly. Ask a virtual assistant, write a Python regular expression that matches a 10-digit phone number with hyphens. Yeah, I've done that. Python regular expression that matches a street address with a number and a street name followed by ST or avenue, or AVE, which stands for street or avenue. Write a Python regular expression that matches a full name with any common title like Mr. or Mrs., followed by any number of names beginning with capital letters, possibly with hyphens between some names. And if you want to see something more complicated, asking for a regular expression that matches any legal URL. A regular expression often has the letter R before the quotation marks, which indicates that it is a raw string. For more information, ask virtual assistant what is a raw string in Python. So a raw string is, it's actually, I think the correct term is string literal. I'm not sure if raw string and string literal are the same, but I think the raw string is literally the string. We are passing in literally the string, versus something like, even if you don't have an F string, a regular string can also have some special stuff in it. For example, a new line character, like if you have the /n, I don't know if this is back or forward slash, but whichever this one is, that and then n, that's a new line character, meaning when, for example, if you pass something with a string with a new line character to like the print statement, it'll print all the way up to the new line character, and then at the new line character, it'll do a line break and it'll continue from the next line after that. So if you say R, you're just saying like there's no special characters this is everything, right? At least that's my understanding of it. Okay, exercise. See if you can write a function that does the same thing as the shell command head. It should take as arguments the name of the file, read the number of lines to read, and the name of the file to write the lines into. If the third parameter is none, it should display the lines rather than write them to a file. Consider asking a virtual assistant for help, but if you do, tell it not to use a with statement or a try statement. Okay, yeah, I think it's just trying to make this a little bit harder for you. Or maybe it's just trying to stop you from coming across something that they'll get to in the book later and could be a slightly advanced concept, because with and try is a slightly advanced concept. Exercise. Wordle is an online word game where the objective is to guess a 5-letter word in 6 or fewer attempts. Each attempt has to be recognized as a word, not including proper nouns. After each attempt, you get information about which of the letters they guessed appear in the try and which ones are in the correct. For example, something about Wordle. I don't care. Just some sort of rejects thing that's happening. Probably. I don't really care. Suppose you guess the word totem and learn that E is still not in the right place, but the M is. How many words are left? Okay. Count of Monte Cristo is another novel in particular. It says shameless in its repetition of the same objective and mentions in particular the number of times its characters either shudder or turn pale. To see whether his objection is valid, let's count the number of lines. Okay. It's just another string operation function. Yeah, well, good stuff. Honestly, I do really like this book. I like it from the accessibility perspective. Like, anyone can do this, and it's all in Google Colab, so you don't even need a powerful computer. Technically, you don't even need a computer. You could use this with like Safari on an iPad, potentially on your phone as well. So I like that aspect of it, but I also really like the exercises in this book. It's really good, and if you're a beginner and you should do this, you should definitely do this. I think it's definitely a positive experience, I think. Yeah. All right. I think that's enough. Ooh, I'm just going to hide that. I don't want my WhatsApp being exposed right now. All right. Take care, everyone. Have a good one. Bye-bye.